Welcome to the VMware Multi-Cloud Podcast. My name is Eric Nielsen, and with me today I have my co-host, David Jasso. David, how are you doing today?
I'm doing well, Eric.
Myself too. We're back from VMworld Europe, and we're excited to be doing another podcast. On the show today, we're going to be talking about multi-cloud application development with Tom Hite, Senior Director of Professional Services, Emerging Technology. Tom, you're on the call here, and you're on video, so how you doing?
I'm doing great, and thanks for having me, Eric.
Yeah, it's great. It's great. I'm excited to hear about what you've been doing. I know, David, Tom's been doing a white paper on some interesting 6.7s topics around application
Yeah, it
development.
sounds intriguing. 6.7s. Hey, Tom, we're glad to have you on the show to talk. But hey, maybe you can tell us a bit about yourself before we get too far, just so folks know who you are and sort of your perspective and where you're coming from.
Yeah, sure. So, two things I'll tell you about myself, but also about my team, because they're pretty important to the 6.7s pattern we'll talk about. One myself, I do run that group you named. Its job in life, so everybody knows, is to contemplate where professional services needs to be as a business, both from a technology and services standpoint. Maybe 6 to even up to 36 months out. So we're a little bit kind of outside the channel of revenue targets, and we're more into the concept of adoption. How in the future are we going to get our customers to adopt our technology for some of the more advanced use cases today that we believe will be normal use cases tomorrow? And I got to VMware through an acquisition about 4 years ago. Well, I guess it's almost 5 years ago now. That's amazing to me. I love it here at VMware, obviously. 5 years went like a day to me. And I got here through Momentum SI when we purchased that company. I was the chief technology officer, and we focused on pretty advanced software development, pretty advanced cloud use cases, even way back then, and pretty advanced container development, the kinds of things that people are just kind of getting into now. So you want to get any hint for my life through other startups that I myself was founder of or on the executive team and sold to public or private entities. I've always been kind of in the future more than on the sale of today with respect to technology. So that's me and my team.
I think when I first met you guys, just comment, you guys had a really heavy focus on DevOps, as I recall. I mean, you were really helping large organizations figure out what that really meant.
Well, we did, and the interesting thing is DevOps is kind of a given. I do a lot of talks on DevOps. It's sort of stayed with me through my career here at VMware, but it's an underpinning concept behind everything. If you think about the topic, even like site reliability engineering, which gets a lot of talk today, that's about software oriented sort of operations, right? But even SRE folks conform to the principles of DevOps because they are software developers. They should do the software development and delivery the right way. And generally, a reasonable DevOps methodology is the way to do that. So, to us and to my team, you'll see it's one of our foci. I can tell you what those are in a sec, but it's one of those that we focus on. In fact, our company's beginning to focus on it. If you look at our transition to modern applications and Kubernetes, and the more we get into Tanzu, a lot of the discussion is starting to focus around developers and making developers successful, which kind of by definition says you're going to talk around the concept of DevOps. And just briefly, I'll tell you what my team focuses on, and DevOps is one of them. That's one of our key areas. We have 6 charters, 6 things to look at for our professional services team, DevOps being one of them, multi-cloud being one. We'll talk a lot about that today. Blockchain being one, because in the future we obviously see that as a major piece of the puzzle for various application forms. IoT, and that sort of draws in machine learning and artificial intelligence in these areas. Modern applications, which is a big topic seemingly today, but as our customers have a transition to make to get there, so we deem that an emerging technology at this point. Compute edge and edge computing, if you're familiar. Those are kind of the big areas in which we spend our time forming both technology strategies and the service strategies around those technologies that our consultants at some point will actually bring to our customers. Good. So there you go. Now you know my team. Kind of know me a little bit.
I have one follow-up question on who you are. I notice you're working out of it looks like a home office. So yeah. Where are you? Where are you based?
I live in Florida. I have a good life. I live on the beach, just a little south of Daytona. It's a town called Ponce Inlet. So We have a pretty good life here.
Very
And that's where
nice.
I'm based.
I,
Although, to be honest, I'm based on a plane because I have a worldwide role, and I'm out quite a bit.
I remember last time I talked to you, Tom, I think a hurricane had just gone through and you were sort of all bottled up in your house.
Oh, was that Dorian? Yeah, Dorian
Yeah.
was reading. Yeah. I told David how it works. Here in Florida, you have what are called hurricane shades. Many people probably know what those are, but
Very nice, very nice. Okay, so why don't we talk a little bit about the white paper and what you guys, what your objectives were in producing that white paper, and take us through a little bit of the intro of that.
Yeah, Tom.
here,
Pick up on
ahead.
also, you and I talked a lot. I just sort of, I'm fascinated by sort of the origins of this. I think a lot of this came out of your engagement with customers.
yeah, I tell you what. So our group is tasked with innovation, right? For PS, let's think about it that way. We're the innovation team, and the 6.7s wasn't something we intended to figure out. Quite frankly, it's like all innovations, and I explain innovation this way to people. Innovation is never a direct intent. It's always indirect. You see something out of the corner of your eye, and I explain it this way. If you think of the GPS system, we got that because a satellite, the Sputnik, flew. Physicists were trying to monitor it, and what they figure out, monitor communications around it, and what they figured out was kind of out of the corner of that is, hey, we can pinpoint that thing. And from there came the GPS system. What we were looking at, David, was trying to figure out if we're really going to do IoT. We were trying to address IoT, and you see a lot of that infusion into the paper. We're trying to address how do you really do IoT at scale. So one of our customers says something like, "Hey, we want to do some IoT." Well, what does that really mean, right? So how do we address the fact that you're going to be moving data from the edge, probably into your private data centers, up to the public cloud, for various reasons, right? Some machine learning here, some re-engagement of those neural network outputs or other analytics graph outputs of that analytics, machine learning. You're going to put that back out on the edge and do some things. But how do you really do that at scale, one? And how do you do it in a secure fashion and in a safe fashion, right? Legally safe, policy safe, all those things. So we started to see a pattern when we looked through this with our customers. And that's literally out of the corner of our eye. We're saying, hey, there's a ubiquitous pattern here to how you address the discussion of how we're going to move data. And when we talk data, you'll see that in the paper, we're not talking content data, maybe data coming off an IoT sensor or something. We're talking all forms of data. Executable data is a container. How do you actually know the rights and reasons you would move a container from one cloud to another? Or, which by definition means, right, you go register it with your Docker registry in the other area. But the point being, how do you do any of that safely, securely, and scalably? And that's from where the 6.7 patterns came from, was really indirect from all of our customers that we were talking to. We're saying, hey, not just what we were talking to. We went and looked at old customers and saw, well, how are they doing it?
That makes sense. And the other thing I noticed, it wasn't just about IoT, but it sort of applies to everything. I mean, you have a great example around a pharmaceutical company in the paper, I think, too, that sort of highlights, how data really works.
Well, so think about the pharmaceutical, right? This is a massive issue for them. They have it's a lot of money that goes into R&D of a drug, for example. And when they're running drug discovery engines, it's very sensitive data that you're going to feed into that drug discovery engine. And here's the cool thing. What comes out ultimately is your drug, right? Now, the output of machine learning might be your neural network that's going to generate your drug, predict the drug. But the point being, that is very sensitive trade secret data. And if it's sitting out on a cloud, you better be well-formed in how you're going to actually wipe that cloud. If your developers have an opportunity to take that data and put it on their laptop to test, maybe new algorithms that they want to test in terms of the model, that's probably a security breach, right? You just put very sensitive data on a laptop that's probably leaving the building. So we have to actually control the data flow, even in the development process, and that's why we raised the pharmaceutical in that case, because we actually work with the pharmaceutical. They really were doing drug discovery across clouds. Very difficult operation, very sensitive from a data security and data scale perspective. And it all has to go right, or they end up, one, they lose their trade secret, or two, they end up in a lawsuit for potentially breaching data, private data about the people that they're testing against. So there you go. It all maps.
So Go ahead.
Go for, well, I have a question on the paper in general and 6.7s, and I know we haven't got into it yet, but is this really a paper about infrastructure and managing the process and procedures for controlling infrastructure and all the data that comes with your application moving in a multi-cloud environment, or is does it also include application development techniques on how you're building your app?
Oh, it's a great question. So this is the 6.7s is more of think of it, it is a pattern that we'll talk about in a sec, but it's a pattern that forms a framework for understanding how you're going to develop and how you're going to actually achieve a multi-cloud application successfully. So it is one of these things, what we call zero product architectures. The point being, we want a ubiquitous pattern to which we'll apply VMware technologies, and where there are gaps, we'll go find third-party pieces that make sense. But we will opinionate our vision of what is right for doing a multi-cloud application, like I said, by having a framework to discuss with our customers what's necessary, what do we really have to understand and go through to figure out what your app needs to look like, right? It's highly distributed, so what does it need to look like?
Right.
And then how do we apply the technologies from VMware successfully? These are what we call recommended service architectures. So think of everything we're going to talk about first in the form of a zero product architecture. So we have a pattern, we have a well-formed architecture, and it really, you could almost apply any technology to it, but what we'll do is opinionate it towards VMware products, and that's how we address our professional services field.
So, Tom, we've kind of kept everybody at bay, but maybe just sort of introduce us at high level what the 6 is and what the 7 is, and then we can start to go into those areas in a little more depth.
Yeah, so 6.7s, and again, we actually backed into that name too. We had to find a name for this crazy stuff we were doing, quite frankly. And 6.7s, just I forget how it came up, but one of the team members just sort of raised it. But it really comes from this. Look, there are 6 process steps we know you will go through, whether ignorantly or not. And ignorance is not a good thing, right? You may potentially miss a step you should be paying attention to. But you will do these 6 things when you're moving data from any failure zone to another, any zone to another. A zone could be a cloud, zone could be a geographical region in your company, but you will do these 6 things one way or another to move your data. And again, data can be content, it's executable data, workloads, whatever. Call anything that represents a transfer of bytes across the network. Think of it that way.
Mm-hmm. So it can be transactional too. It's not just, as you said,
well, dude, you're pumping data from REST calls from one microservice to another. You are transferring data across that REST call. So that absolutely, messages that go between microservices are data transfers. And when you look at the 6 process steps, anytime you have a process, what you don't want to do is have a human kind of in the loop of that process to the extent you can help it, right? You end up in scale problems. So the 7 foundations comes from what are the 7 foundations it takes and what are underneath each of those foundations of technologies to automate the process of the 6 steps. And I'll just explain them real quickly. It's not too hard. You know, the 6 steps you'll go through in any data movement is first you'll describe your data. You got to know what it is. Is it sensitive data? Is it, publicly known data? What's the nature of the data itself? Okay. And if we know the nature of data, we can partition it. And the reason we raise partitioning is, think of our IoT use case where there's massive amounts of data coming from a very large number of potential endpoint devices in the edge, right? That's probably going into a data lake. And to the extent we can partition that data lake in a way that makes sense, both from a governance perspective, we'll talk about later, and from a removable, right? Can we take a certain portion of data? Do we know what we can take and move to another cloud to go do analytics, for example, right? So once we know what the data is, we described it, we can probably partition it and partition it well. That also helps us around governance, right? Data governance is a big topic nowadays. And if we can partition it, that informs us where we can place it because we know how big it is. If it's really, really big, we're probably not going to place it too far away because it takes a long time to move it, right? We have a data gravity problem. In other terms, that's called an availability problem. We'll talk about in a sec. But if we can place it, right, now we know where to place it and how to place it, on what kind of storage. It informs lots of things around that. Do we need to encrypt it in flight, right? Then if we know those things, we can now build connectivity and access, right? Build the networks, if you think about it. So think about this for a second. SDN stands for Software Defined Networks. A majority of our customers, and I don't have actual data on this, but every time I ask a crew when I'm speaking of our customers, I ask them, are you statically defining your networks? And the answer is yeah, they usually define their networks up front and they leave them up. Well, SDN stands for Software Defined Networks, not statically defined networks. So if you do things right, you know your data, you know you can partition, and you know where to place it, you now have the definition of what you need from an access standpoint, network standpoint, to actually connect the two sides of the world and transfer that data. Here's the cool thing. You should then tear that network down. There's no reason to leave it up if you don't need to transfer things in the future.
Mm-hmm. So you could be much more dynamic, and you can sort of adjust to the circumstance you have at the moment, and not sort of always be sort of living with a static set of environments that may or may cause you problems in the future.
Right. This is VMware is all about software-defined everything, right? Software-defined data center. This should be very dynamic. In fact, it's actually a security increase, if you will, to drop your networks, right? You just dropped all the attack services that network leaves open. It's gone. No one can come in and go get it. So anyway, that's...
Before you move off of the six and the process patterns, I had a question for you. I assume as you go through that, you're also thinking about data transformations, right? Because that's sort of what has to happen to the data as part of that process.
Okay, so hold on that thought. We're going to get there in a sec.
Okay.
That's literally next. Interesting you got there. So once we've built the connectivity and access, means we've transferred it, we know the storage we're putting it on, we've built all that. Then we're going to process, right? Exactly what you're talking about. We're going to do either, if it's a simple thing like transferring information off an IoT sensor, we're probably just going to transform the message and put it in a Kafka topic or something like that, right? We're just going to do something to transform. There might be much broader transformations, which is a machine learning algorithm, right? We may actually want to transfer a large amount of data to transfer that into the learning algorithms, and out of which we get a neural network. That becomes our new executable that we're going to move somewhere else. Well, there you have a new problem. You're going to move that new data somewhere else. You're going to recursively look at these 6 data processes that we're talking about. The final step, once we have processed it, whatever we've done, we've got to clean up. So let's say we move it to a public cloud, and we're a military organization, and it turns out AWS, for example, just an example, but all these clouds are similar. Their wipe mechanisms don't conform to the needs of a military-grade wiping. So we actually have to wipe things successfully. So these 6 steps will occur. You'll describe your data. You'll partition it, whether you meant to or not. You might be doing these ignorantly. You'll place it. You'll build your connectivity and access, whether you're doing that most expeditiously and most securely, I don't know, but that's what we want to address. You'll then process the data, and you'll clean things up. Those 6 steps are going to happen one way or another. And that's the 6 process steps of the 6 steps.
Yeah,
it's the foundation. Go ahead.
I was going to say, what caught my eye when I first read the paper was this idea that doesn't seem like the typical way people think about application development. They kind of start with what has to happen, what's the business logic that has to happen, and what are the manipulations and things like that, and sort of they come to the data later. This is almost a different approach around how do you think about developing applications, it seems to me.
Yeah, but it covers kind of all layers. We're an infrastructure company. We should be building infrastructure that supports the need of a developer to think just like you just said. Yeah. All they want to know is what's the business logic, because that's the feature they want to write. That's a feature developer.
Yeah,
but the SRE, who's a developer as well, has to automate the infrastructure into which they're going to lay that feature, right? So all this stuff is what the SRE kind of has to worry about. We don't think of SRE as a developer in a lot of cases. They have to develop this process and automate that thing and do it successfully and at scale. That's the hard part.
I guess where I was coming at, it seems to me when I first read the paper, this seemed like a nice augmentation to the way people build software. That you want to sort of do whatever your traditional process is, but this is a nice thing to add that makes sure you really consider the application from the data side.
Yeah, and tell you what. Various customers, our healthcare customers, military customers that we have, insurance carriers and things like that, they've all, when they first walk through those 6 steps with us, a lot of the inclination is at first is, man, we don't want to see this because this just raises all sorts of issues we have to worry about. And that's a very interesting, that's paraphrasing by the way.
Yeah.
That's a very interesting statement. It's like, we almost don't have time to think about doing things safely and securely. That's not exactly what they're saying, but you catch the point, right? We'd like to gloss over this and just get to getting applications deployed. Very dangerous scenario. So yeah, that's why it's different thinking. We know what's going to happen.
You must You must feel when they tell you that, like, okay, I've done my job, right?
Well, sort of. What I don't want it to do is scare people. I want it to make them recognize there are considerations here we should make. Tearing down networks isn't comfortable for people, right? They're like, oh man, then we got to build it back up. If you automate that in a CI/CD pipeline, you have proper DevOps. Quite frankly, it's nothing. It's automated, right? So think about it that way. And the way, by the way, we do this automatically is we think about the 7 foundations, and that's where the 7 comes from. What are the foundations of technology that we have to put in place to automate those 6 process steps? Well, one is a valid data classification piece, right? We've got to have, there's different data classification softwares. VMware doesn't write them, but our consultants ultimately will have to help our customers think through this and help them implement their own data classification efforts, right? If you think of banks, most of our really good customers do. In fact, VMware has a very sophisticated data classification implementation. I don't know if you guys even know that. Most people don't know that. We're very good at this stuff, and a lot of our customers are too. They know what to explain data classification.
Yeah, I was going to say, can you give us an example?
Yeah, there's 3 things you really worry about. There's more than this, but 3 things kind of top of mind. A lot of people refer to these as the 3 NSA issues. It's confidentiality, availability, and integrity. Your data has to remain confidential to the extent it needs to remain confidential, high integrity to the extent it needs to remain high integrity, and available to the extent it needs to be highly available. These 3 things are important. And a breach of any one of them, these are called the security objectives of data, whether it be, again, content, containers, VMDKs, any of this. Those 3 things, if you breach one of them, there's going to be an impact. And the impact might be life-threatening. If we breach the confidentiality of, for example, in the US, and a CIA agent, that's potentially life-threatening. That's a very bad situation, right? So what are the breach issues around the data of a security objective? What are the impact? And do we have a process for dealing with that impact? Do we have reporting characteristics? Guess what? Blockchain comes into reporting characteristics because multiple parties need to trust that that report is correct and that that report is real. And now they really do have to protect that CIA agent, for example. So different technologies come in. So data classification is how we describe the data we're dealing with. We describe it. We know what it is. We know what the impact of its breach is.
So if you look at those 6 processes, you've gone through that, then you start to apply these on top of that, right? So you get now you sort of know the universe of your data, and you start to apply these foundations on top of that.
Right. And the second technology, the second foundation is governance, right? So governance is right. It's the mechanism by which we define policy and subsequently enforce it. So governance is pretty important from a data perspective, because who gets access to data? Who should get to see it? And should it flow in various CI/CD pipelines, right? Your developers might see it. They might be able to move it off into their laptop. So governance around everything is crucial. So governance is all sorts of things, right? How are you governing your secrets? How are you governing the access to your secrets? How are you generating them? What about your certs? What's your search management strategy? What's your strategy for defining in which cloud we want to run something from a financial perspective, right? That's financial governance. Great for our cloud health organization. We know, as VMware, probably the best place to run things, so we can do these things. So governance ends up being a pretty big issue with respect to data movement, right? By definition. Observability. Observability is a tough one in the software industry. They just can't ever find it. If you really boil it down to what it really is, it comes from control theory. Can we understand the state of a system or infer it from its outputs, right? Meaning, can we understand the quality or the state of our software running across clouds in a way that we know how well it's working? Think of it that way, right? And if it's not working well, let's say we have a governance problem. Not working well means we breached a security objective. We leaked a certificate somehow. How do we leak it? Well, observability should tell us that, right? Observability should know, one, that it leaked. That's the state of the system, not a good thing. And it should help inform us what's broken. How do we find what's broken? If there's latency issues, things like the predictable response time controller Mod's working on. These kinds of things are observability plays, and observability becomes an important concept in the foundations to automate. Are we monitoring? Are we logging everything? Are we auditable? Do we have it in a way that our auditors can see it? Are we doing distributed tracing successfully across our microservices? All that stuff comes into play. And then comes security, right? If we're moving data, by definition, some of it does need to be secured, right? Security comes in all sorts of forms. We need to assure there's no attacks coming in, cybersecurity, Carbon Black, our play.
Hmm.
We need to ensure that when we're moving secure, sensitive data, it's moving on encrypted channels, right? We should be able to build those channels on need, not just we're going to encrypt everything because we don't really know. You just ate up 1/3 of your bandwidth just because you decided you didn't know. So we can build the security into all these things, right? App defense being another play. What process should be allowed to run,
Hmm.
right? That's what defense helps us do. Should it be allowed to run? And even if it is allowed to run, is there a cloud in which we want to let that run? So that these two things kind of go together. So think of security from that perspective, not just NetSec, right? Firewalling, east-west firewalling, microsegmentation, that sort of thing. Think of it in the whole scope of security. When we move data, how do we know it's secure? And how do we know our third parties that we're giving it to potentially are similarly secure? Can we have the same conversation with six
Yeah,
sevens with them?
you hit on
If
a pretty big point there. The things you're talking about are sort of universal, right? They cut across all layers of the application, the different clouds. There's not one technology or something that solves all these problems, right? I mean,
No, there's not, and that's why why we kind of propose. Look, this is pretty ubiquitous. This is a pattern that sort of hits each layer no matter what. Um, so anyway, we figure out the other three being storage, right? Storage needs to exist in every cloud if we're going to move data across clouds, right? The problem with storage is it always looks different. What's your unified view? I need 1,500 IOPS. How does a developer know he gets 1,500 IOPS just because he asked for a storage class in Kubernetes? It should be a guaranteed situation for him. He shouldn't have to worry about it. But the SRE should be able to move those workloads to any cloud without worry through the CI/CD pipelines, deploy it through the pipelines. And here's the deal. Storage is more than just block storage, right? It's all about, do we need object stores? Do we need shared file systems? Is NFS good enough? Maybe. Do we need IPFS? Something like that. There's different types of storage that we actually have to combine and unify across the clouds to make successful. Obviously, if we have vSAN everywhere, that gives us a basis, but it still doesn't tell us how NFS is going to be, right? So there's different layers here. So we need to worry about storage because that's the place we're going to place data. And that's the place we may need on disk encryption. We may need different capabilities, right? So that has to be defined. And networking is a given. By definition, if we're going to move data, network's required, right? So there's physical natures of networks. There's NSXT, of course, and NSXV are products that help us define network switches, the objects, security objects, and that which we define as networking now. So we want to have a product that actually does that properly. If you look, for example, at Essential PKS, you can put just about any container networking interface in there, right?
Mhm.
We can put Calico in there, we can put Flannel in there. We prefer NSXT, but there's a lot of ways of defining how networking is going to get built. And the final piece for the processing is the platform as a service, right? Your PaaS system is important, whether it be Pivotals, their PCF PaaS component, PKS, our VMware PKS component, whether it be in the future. If
Yeah,
we get the PCF functions, we got to have a system that actually is an application platform underlying all the applications.
yeah. Sort of. It seems to me the PaaS important layer where it's sort of you bring a lot of those other foundations together, right? Because that's where sort of the developer interacts with those things to the extent that they do, or they underlie the PaaS.
Yeah, and so here it's an interesting point, David. What we want, from my perspective as VMware, is to make the developer's life unbelievably easy. Let him write the feature. Let her write the feature. Let them deal with the business they need to deal with and deploy it and just ask that it get deployed. The rest of it should be automated. And in order to automate it, these 6 process steps need to be considered. And an SRE needs to build the infrastructure as code and build the underlying hardware systems, everything necessary, and cloud interfaces to actually automate that process. And they do it through those the 7 foundations, the technologies as without. Now, how those all unfold, we have these things called recommended services architectures. For each of those areas of the 7 foundations, there are various products that VMware has. In most cases, there's some we don't. We don't do data classification, for example. But in most areas, we do have pretty good products. And they change based on the nature by which a customer is going to actually deploy. If they're pure on-prem, meaning they're going to be pure SDDC, we know what the products are. They're going to look like VRA, right? They don't need VRA cloud. They just need VRA locally, potentially, probably self-managed. But if they're going to implement things in the cloud and potentially a mix of on-prem, but not using a hybrid scenario like VMC on AWS, they probably want VRA cloud, right? So our products have a change of form in how we're going to deploy a successful customer solution. So we have these things called recommended service architectures. There's about 100 line items to cover these 7 foundations and the subsections of each of those that we would sort of give our sales force, hey, if they're going to implement a real multi-cloud solution and they're going to be mostly using public cloud services, here's your products that you'll want to implement. If they're going to be hybrid or a mix of public cloud and standard SDDC, VMware SDDC, here's the products and how they line up. And if there's mostly on-prem, here's how they line up. So they can kind of pick and choose and just literally line it up, pick the products, the services then attached to that, and they should be able to go ultimately implement a really good multi-cloud system for the customer. That's literally what the 6.7 is for, to make it that easy.
Okay, I'm gonna hit you with a couple questions here because I've been listening for a while, trying to stay awake from my European time zone shift that we got going on.
I thought it was because I was getting boring.
Yeah,
dude.
no, you're not boring. It's good. It's just we got that European time zone jet lag going. How much of this is greenfield versus how much is brownfield? When you're an architect and you're living in an environment in your world where you're already developing a lot of software, in your practice, Tom, like, what are you seeing? Is this mostly when you're going to go build a new application that you can go ahead and apply some of this pattern?
So that is an intriguing question. One no one's asked yet. It's intended for both brownfield and greenfield, and I'm going to address it this way. If you look at our focus areas, we tend to focus on fairly new things, right? So our customers that we deal with, my team deals with. By the way, we're not a practice, just to be clear. We are a research team, so when we engage with customers, it's usually in a non-billing situation, but we do help our delivery team in a lot of cases. And we're meaning it that way because not all these things are perfectly figured out yet. In a lot of cases, we want to address a customer and let them know, hey, we're at the edge here. We want to work with you to really sort of validate our thinking. But that said, a lot of this is greenfield, I'll be honest, but greenfield is a funny term. So when you look at a modern application, for example, which is a hot topic today, right? A modern application, as we define it for the field, is very simple. It's a resilient, multi-cloud supportive, orchestrated release of VMs, containers, and potentially serverless functions. And we define it that way for this reason. You're probably going to use multi-cloud. We know that because if you look at Gartner studies, on the range of 80, 81, 82% of all customers are already using multiple clouds. And more than likely, the respondents to those surveys are our customers. So they're already there. We need multi-cloud support. We need resilience, which is kind of the nature of writing a microservice or a highly distributed app on Kubernetes. This is the idea in the world of cloud native applications is resilience, written in the application versus in things like vMotion. But guess what? Those new applications are probably going to get written as new services around existing VMs. So that's what makes it brownfields. SAP, for example, or Oracle RAC, or other large-scale systems that are currently running in VMs. If you look at some of our customers, I just visited one of VMworld Europe, 39,000 VMs are running their business, okay? That's a lot of VMs. They aren't just going to stop those and go make all new microservices. Not going to happen.
Right.
The modern app is really a mix of these microservices in a cloud native form, communicating, potentially facading, or in some way interacting with those VMs in many cases. Right. It's that nature. We're now multi-cloud, and it kind of forces this discussion. Well, I can't move those apps. I can't move the data they have. Really, maybe what I need to do is write some services that expose that data to the other cloud. And
Yeah.
this is where the conversation comes
Right.
from. It's this-
That's why I actually was asking the question, because when we've had other guests come in and talk about it, there is greenfield apps, right? But there's always a tie back either into infrastructure or into existing services that you're going to be engaging with. And I just wondered how, when I look at the 7 functions here and the diagram you have in your blog article, it's like I wonder how that plugs into existing frameworks and what I'm dealing with in order to actually architect the next application. And if it's greenfield, it's great. I'm building lots of services, and I can build a whole new architecture. But a lot of times in the world that we've been hearing other guests talk about, they're talking about this need to tie it into either existing infrastructure or some existing applications.
Yeah, look, how long, I've been alive a long time. How long we've been talking about the death of the mainframe? It's still not dead. So
Yeah, I stopped talking about it.
it's going to be a very long time before we realistically have the death of the VM. And I don't mean that from a VM from a technology perspective. I mean, there's good reasons people run certain workloads in virtual machines versus container form. Okay, there's actually good reasons for that. It's probably going to be around for a while. But more importantly, I think to what you're referring is, there's a lot of work in replacing an existing application. Think of it in the old days, we kept trying to sunset mainframes. There's a lot of work in ripping those apart, trying to make them work in a highly distributed fashion and make them successful. We can do it. It's just a lot of money spent, and you're not writing any new features. I think what companies really want to do is focus on new features, new revenue channels, and that's where they'll write the cloud native applications. That's greenfield-ish. But as you said, it's going to tie back to the stuff that already exists, because that's where the current data exists. And that's what we use to move. And as our 6.7's paper says, the whole idea of software is to add value to information flowing between software components. That's what it's for. That's what software does. So that data is going to have to move, dude. I just believe every system will be brownfield for the foreseeable future.
Sure.
Hey, Tom, related to that, and sort of, the 6.7's pattern, the combination of the data orchestration and then the app dev foundations, way I think about it makes perfect sense. You're looking at a brand new app. Have you experienced anybody going back and looking at an existing app, or either as maybe whether extending the app to apply it? It seems to be that probably a lot of people didn't think about this up front. So you've got a lot of apps.
So a lot of existing apps so it's usually the reach to expand scale, reach to expand flexibility, or the reach to expand developer productivity, right? Which is effectively the reach to AWS or the reach to Azure or the reach to GCP, right? This is why they're going there. It's not so much the app, quite honestly, that gets a company to start thinking about a pattern like the 6.7's. It's more when they start to spread outside the confines of their very well-formed and very tight internal data center.
Okay, makes sense.
Right.
If it's internal, you don't have a lot of danger, right? You're kind of in there. I mean, there's some dangers, but at least you have reasonable local control of it. The minute you start spreading around, life gets a little different, and that's when they have to start thinking about it. And quite frankly, David, it's because the CIOs have initiatives to get 2/3 of their workloads, for example, out in the public cloud. Now they're going, great.
Yeah.
I've got a whole new attack surface out there. There's vectors all over the place. What do I do now? So,
I'll ask you another question on this, on observability and the whole pattern in general. Do you see some areas that are more difficult than other areas, and where when you start to build an application, you run into trouble? And I know we talked about other people where you tend to build it and then you spend another year trying to make it work, because there are places here that are hotspots that you probably need, as an architect, need to think about.
Yeah, I'll be honest, the hard part, honestly, for companies and ourselves, is data description, data classification. And the reason for that is that's, to a large extent, if you tried to classify every piece of data in your organization, you'll run out of money first. You can't do it. So literally, it's financially intractable. The hard part has been identifying the important pieces of data that we do have to care for, and we do have to automate the process around these 6 processes around, and allowing ourselves to throw the rest away, because a lot of it may be public information, right? So find out from a financial perspective, what can we really do to automate the world of the 6.7's, right? That's the hard part. The concept of governance, observability, that's, you know, everybody doesn't do it perfectly, but they know it can be done. We have products, VRA, we have products all over the place that can do well-formed governance, well-formed observability, right?
Right.
Log insight, log intelligence.
Right. There's products that address that versus data classification you almost have to do on your own because it's your data you have to figure out. Versus when you get into governance and observability, there are a lot of software products that do that kind of stuff.
Yeah, and to some extent, we're not telling people how to architect their application. We'll help them with that. That's right. When we're doing, for example, high-scale IoT systems.
Right.
When you get into scalability like data movement and latencies and this, that's actually an availability problem. It's a breach of, and when you start thinking like this, that's a breach of one of the security objectives of data classification. If we have a latency problem, that's an availability problem, right? By definition, you didn't get your data in time, so it's not available. So it turns out everything can tie back to the data classification, the 3 security objectives: availability, integrity, and confidentiality. When you tie it back like that, things get a lot easier, and you can make SLOs that the SREs need to address and automate and make better and those sorts of things. But not everything needs to be classified, quite frankly. And I think that's the biggest fear for customers is, oh, geez, it sounds like master data management, which was, kind of a terrible situation itself. And the answer is no. What we want to do is for the major pieces of the puzzle, let's really understand what the data is. Let's really understand what the main flow is, where your risks are with respect to legal risks, operational risks, right, and potential availability risks or breach risks, that kind of thing. So that's the hardest part.
Okay.
The rest of it, quite frankly, it's software delivery, man. We know how to do that part. Everybody does, I think, our customers.
Hey, Tom, you were talking about, everybody's going to do these 6 steps. You're either going to do them consciously or unconsciously. Curious, how many of the folks you run into sort of have a good sense of this, that there is a process here and that you need to follow it, or are they just sort of blind to most people not thinking about this at all?
Yeah, no, our customers are pretty good. Let's be honest. Like I said, most of them that I deal with have pretty well formed data classification situations. So they're actually in pretty good position to do the kind of work we think about. What I kind of catch, or we catch a lot from the CTOs and CIOs we talk to, and their architects is, hey man, we thought of 4 of these, we kind of missed 3 of them. So I think our customers are really good about recognizing this is a concept we have to address. And what we can do is add value by having, we got 500,000 customers we get to look at and see where to go here. They don't. They get 1, that's themselves. So where we can add value is bring the 6, maybe they thought, or in the 7 foundations, maybe they're ready for 4, or they thought about 4 other process steps and 5 of the foundations to automate that. They're probably pretty good in getting there. Our job is to just augment them and make them a little bit better. So that's how we look at it, David.
Okay, cool.
Other thing that I'd like to ask, which I always like to drill down a little bit, is when you're talking about people, education, architecture, are there things that, when, I'm an architect right now, I've architected multiple solutions. Are there things that people should be reading or training themselves on? How do you grow enough to understand how to build something like this? Because I think it's one of those things, if you don't know about Fight Club, you're not going to know about it, right? And how do I acquire this knowledge? Because you hit on a really cool point, which is at VMware, we're looking at many thousands of customers, right? When I worked, running a data center and we were architecting solutions, you're just looking at yourself. What's the best way to other than read and, engage, I guess?
Yeah, so there's actually a lot of information. So our group, we do publish a lot. We obviously publish this white paper. We're publishing subsequent blogs around these. So there's already one around observability. That's been published. Already one around data governance, data classification. We're adding 3 or 4 more as we go here in the next couple of weeks. So we're putting out a lot of content. Obviously, we represent ourselves at VMworld because we've been invited in many cases. Just, hey, come on and discuss these things. This and some others. So there's that. I also think it's fair to look at other third parties. NIST, for example, which is a U.S. federal agency, right? This is a very good group. I mean, when you look at NIST documentation, it's extremely well formed. And you'll find, even in our paper, we cite much of the 3Security groups around the NIST layer. And if you look at a lot of, for example, a lot of companies, even VMware's model of their data classification, it's centered around the NIST sort of description model. And in fact, other countries look to that as well. So the hard part, I think, is first at least seeing somebody put something like the 6.7s out there, so that at least there's a framework. And we have a lot of sites in our paper, and there's a subsequent piece. Just go read it. It is a need to read. And I'm going to tell you the truth about the third part. If you haven't actually built a globally scalable software solution, you probably don't know how to do it yet. In my position is, that's okay. We have at VMware, my teams have, I have personally in the startups I've built and other scenarios. This is a thing you can come to VMware and get help. Just ask. It's really that simple. We're not here to run you out of money. We're actually literally here to help our customers do these things in the hopes that they'll use our product. But you don't see a product named at all, I don't think, in the 6.7 paper. That's not what we're intending. We're intending to give this info out so you will trust us as a trusted partner over time as a customer to come in and help you. That's it, dude. I mean,
yeah, that's a great answer, and it's the truth, and we're in a position to do that because we do work with so many customers that are at this same phase or have already gone through the phase. There's always somebody that's done it before us, right? And there's always somebody doing it after us. And so,
I love this quote I've used before, but life's too short to make all the mistakes on your own. You've got to learn from other people's mistakes.
If you've ever done a startup, what investors want to know, for example, is, I'm going to use a bad word here probably, but have you been to hell and back? Have you actually done things like this before? And have you seen the flameouts? And have you seen the pain of failure?
Right.
Well, the answer is yes. And if you have, then you know where those failures can be. And this is what we've seen for years at VMware. We don't see failure that often, but the point being, we've seen what that looks like. We've seen what success is. And we have so many scenarios we can look at and help a customer through the really difficult part. So yeah, that's the hard part. Have you built it before? If you have, you probably know how to do it. If you have not, you will find flameouts. And those are the hard things to get through. We can take you around those. That's kind of the way I put it to people.
So we're running up to 2020. The new year's going to start. Do you guys have some major objectives or things that you're working on to discover to build more content for us? What are some of the hot spots that you guys are working on?
Yeah. So interestingly enough, as we went down these paths in IoT and machine learning and lots of very cool implementations, some with customers, some internally, the company asked us, hey, why don't you bring yourselves back closer to the market and really dig into modern applications in a way that conforms to what you're talking about? So we're actually putting out a lot of content around what is a modern application, how do you develop it, how do you conform it to the kinds of things we talk about here, high scale, high security, and high scalability, these kinds of things. How do you really do that from a consultative perspective? And we keep our other concepts, right? Edge computing changes the nature of things a lot. So we're studying a lot and building a lot of technologies and content around edge computing, but not just compute edge, right? Which is dimension, if you think about it that way, putting infrastructure in place to do things. It's what are you doing out there and what is appropriate to do out there on the edge from a computational standpoint? Can we really do machine learning out there or do it distributed? And again, that will bring you right back to multi-cloud problems, but also scale problems at the edge. So looking a lot there, and believe it or not, we're looking now, it's kind of way out there, but where does augmented reality fit the world of managing applications while they're operating across clouds? And it's much easier to do things visually for a lot of people than it is to think, from a technical perspective, writing code. So we're thinking about those things a little bit. But to be honest, we're bringing back a little bit because, like I said, we've been out in the future for ways. We kind of know what it looks like. It's not so fuzzy anymore. For the next, probably this half and first half of 2020, we're going to really focus on helping our company transition our customers into the modern app era. And you'll see that means bringing in blockchain, bringing in off-chain storage with respect to blockchains. These are not things people think about, and helping customers actually achieve success in those areas. So maybe that's not as thrilling as you want to hear.
No, but we get into that position a lot in our team where we can dream up a lot of things pretty quickly, right? And we can then define what that is and do some research on it. But then at some point, you have to come back and actually work on material processes, white papers, helping customers, do where the industry is going. And so actually stopping and going, now how do we actually bring this to practice, right, to our customers? And spending a year focusing on that is a great objective, because it's so easy just to dream up things and then not do the hard lifting of building solutions for and white papers and all the stuff you need to be able to allow me running a data center or architecting solutions to actually accomplish it.
Yeah, and we're the things we're researching out on the edge are truly that. What does it look like to create a truly sustainable, right? No fossil fuel power, multi-cloud solution. Those are things companies are thinking about. They don't need an answer to that yet. So we'll continue the research around those areas.
Right.
But like you said, we're gonna spend a little more time than we planned originally on bringing that back in the next half, so into modern apps.
So you mentioned a blog. Do we happen to know what the blog actually, where you're publishing this stuff?
We can post links. Our blogs are pushed through various feeds at VMware. Some of them are Octo feeds.
Okay.
Some of them are marketing feeds, and some of them are professional services, educational feeds. So they're quite a ways around. But we do have a page where everything's listed. It's on Vault. Now our public, I don't know if you guys are going to pump this out to the public, but our public customers probably can't see that.
Okay, great.
All right.
Yep. So we'll take a look at this one as a practice, and we'll see if we can get it published out to the world. Does this the white paper I have in front of me? Is that a consumable by the public?
Yeah, that's already published by VMware. So that's a VMware paper.
All right, we'll get a link up when we publish it. The podcast.
You can find it easily too, but just search in 6.7's VMware, you'll get it.
All right, perfect. I know we're running up near the end of the hour, so Tom, I'll ask you this. I know what the answer could be. You happen to be on Twitter. Can people follow you?
I am on Twitter at TD Height. That's Thomas Dean Height. If you really want to know. That's
TD Height, HITE.
Yeah, HITE. T
right.
is in Tom, D is in Dean. That's my middle name. Height, HITE.
HITE. All right, give Tom a follow. Tom, it's always great to see you. David, what else?
Awesome,
what else
Tom.
We got? Yep. Good to see you. We're coming up to Thanksgiving, so hope you have a great holiday season if you're into that kind of stuff. And thanks for being here, and keep up the good work.
Yeah, thanks, guys.
Good
Pleasure.
talking, Tom.
Thanks a lot.